Okay, in the last video, we talked about the threats to IoT applications. So in this video, we'll talk about how we can mitigate the threats. Yeah, we use the word mitigate because theoretically it cannot be removed totally. So consider that the heterogeneity of the application space, we need to use a suite of techniques. So most of the time, we need to use a combination of different techniques. So we will once again use the layered approach to examine the various threats and suggest potential defenses. One thing to keep in mind is that we need to implement the security mechanism specified in the associate standards. For example, if you are using Wi-Fi, then you need to apply the security mechanism specified in the Wi-Fi, right? So you don't want to mess up the Wi-Fi protocol itself. So application layer attacks, so that's the top layer, okay, that are designed to compromise the regular operation of system. So attacks for this attacks from this layer, including the overwhelming sensor with the spurious diagram and path-based denial of service attack, eavesdropping and physical capture and programming. So what we can do, detecting and also for the physical attack, it's quite difficult to detect and mitigate. So we need to have a realistic model of overall systems expect behavior, so that it can assist us in determining whether signal in a sensor data that might otherwise require a response in effect of a real event. So for example, if you are measuring the temperature of the body, right? Usually it will not go to 200 Fahrenheit, right? So that's one thing. Well, during the programming, during the design of the system, we can set some threshold or limits there so that it goes out of the limits, we know something is wrong. And also we need to have the understanding of the potential failure modes of the system, in addition to under the portable range of sensor readings. Basically, to put it simple, we need to know the system and what numbers are expected. So if something go crazy, we can identify them. So physical capture attacks, reprogramming, or malware that is otherwise capable of manipulating system performance are essential to prevent insofar as possible. So in the case, we can use the encrypted microcontroller cores and memory. Concerning eavesdropping, on network traffic or DOS attacks, and we can use the cytographic mechanism. Basically, okay, you can catch my signal, but you cannot understand what, right? And if we have authentication, so you can either change the content. So that's another kind of secure. Yeah, also we can reject the replay, so that we know this is replayed for the devices that are physically adjustable and accessible over public network infrastructure. Should always adopt internet standard security and should never be online without disabling factory default security settings. So actually this is quite important for IoT because IoT use internet most of the time as the backbone, right? Okay, for the transport layer. So the most probable attack are denial of service, basically by flooding and by desynchronization. So what we can do is to use authentication. Basically, we make sure the identity of the device and authenticate it. For the network layer, so once again, several DOS tests are possible, including what we mentioned here. Once again, we need to use encryption, authentication, authorization, redundancy, and traffic monitoring to protect and mitigate. Yeah, for the silver attacks and wormhole attack, we can also make them preventable by using effective authentication and authorization policies. Now we are moving down for the data link and medium access control layer. The DOS attacks is quite often. So in that case, we can use the techniques like error correcting nodes, rate limitation, and frame size reduction. Integration and civil can be handled by encryption and authentication mechanisms. So for this, for the contents mentioned in this video, the requirement is that given a attack type in a specific layer, you should be able to find out the countermeasure. So that's the requirement. So for the countermeasure, so you don't need to go to too much detail. But if you're interested, actually it is very interesting to learn more. For the physical layer, we have the attack in the form of tampering. Yeah. DOS in the form of jamming and civil attack possible. So what we can do is to spread spectrum or mode changing techniques, and authentication again is a primary defense. So just now we talked about some countermeasures, but in addition to taking some countermeasures after something happened, what we can do is to, by design, to have the security element in the architectures and the standards. So in this chapter, we have two examples. So it's from the IETF and the 3GPP. So you just need to know their names. So when we talk about them, you just need to have the idea of that, okay, they are dealing with the security in architecture and standards. So that's good enough. So I include some additional reading here. So yeah, feel free to read it if you're interested and want to learn more.